Hi there, my name is Mark and this is Pacific Northwest Solar. Our family has a solar array installed at our property in rural western Washington state, on the west coast of the United States. I've been inspired by other YouTubers to share my experience with our solar array and how it impacts my power costs. This video details my results for all of 2025, and I hope it will be useful information if you are considering getting solar at your home. Please also see the link to my separate video that gives more details on our installation, listed below in the description. Here is a picture of the Sense device that measures my power usage and solar energy generation. It is located inside my electrical panel and clamps sensors onto the wires. This graph shows the entire picture for the whole year of 2025. An astounding total of 19.4 megawatt hours of electricity were generated. Over the course of the entire year, the generation exceeded the usage by about 805 kilowatt hours. I'm super pleased with how the system performs. Here is a picture of our 16 kilowatt ground mount solar array. The solar array is directly south facing in one of our pastures with no trees or other obstructions around it. We have 50 ZN shine panels, rated for 320 watts each, with Hoy-Miles M300 microinverters on the backs of the panels. These microinverters convert the panel's DC output to 240 volt AC power, which is sent back to the breaker panel at the house. There is only one choice of electricity providers where we live. Currently, the cost of electricity from the grid is the same no matter what day or time it's consumed, no time of use rates. Any power generated automatically goes to usage in the house first, and then any additional is automatically returned to the grid. We get a 1-to-1 credit for each kilowatt hour that we send back to the grid. These credits directly deduct from the power we are charged at the end of the month. As you can imagine, the overall idea is to overproduce in the summer and use the credits to reduce or eliminate the electricity bill in late fall and winter months. I am using the Sense device in my electric panel to track power generated and power consumed, and I have written a custom Python program to capture real-time metrics for the entire system that I save and analyze. Here is a day-by-day chart for all of 2025, showing solar energy production and usage across the entire year. The highest day of solar production was June 1st, where a whopping 110 kilowatt hours of energy were generated. In contrast, the highest usage day was January 13th, when a total of 113 kilowatt hours of energy were consumed. The overall pattern of solar production being lower at the start and end of the year versus the middle of the year, which is summer, makes sense. This chart shows the solar generation and power usage on the highest usage day of the year, January 13. The temperatures on this day were from a low of 28 degrees Fahrenheit, -3 Celsius, to a high of 35 degrees Fahrenheit, 2 Celsius. The total usage was 113 kilowatt hours, which was very high indeed. The electric furnace came on a total of 10 times during the day. The total solar generation was only 10 kilowatt hours for the day, which is quite low, but certainly not the lowest I've seen. You can also see the baseline usage drop near the end of the day, where I turned down the heater that keeps the garage from freezing, as it was at a higher temperature than it needed to be. This chart shows the solar generation and power usage on the highest generation day of the year, June 1st. The temperatures on this day were from a low of 42 degrees Fahrenheit, 6 Celsius, to a high of 67 degrees Fahrenheit, 19 Celsius. The total usage was 30 kilowatt hours, which was pretty typical for a day with no electric furnace or air conditioning usage. The total solar generation was 113 kilowatt hours for the day, which is the highest figure I've seen. Here are some additional interesting facts about my usage in 2025 that I got from Gemini's analysis of my data. The minimum power draw for my house measured 337 watts for any sample for the year, and this happened on June 5th at 6:34 a.m. The maximum draw was an amazing 27.8 kilowatts, which must have been when the electric furnace was on, as well as the water heater, the electric oven, and some other appliances. This maximum occurred on June 5th at 6:34 a.m. The average or mean was just over 2.1 kilowatts per sample, with the median being somewhat lower at 1.1 kilowatts per sample, and the mode being 797 watts per sample. Gemini gives this additional analysis, because the mean greater than median greater than mode, the data has a right-skewed, positively skewed, distribution. The mode, 797W. This is the most frequent power state of the house. It likely represents the resting state of the home when no major appliances are running. The median, 1142W, This is the true middle point. For half of the year, the home is drawing less than 1,142 watts. Here are some additional interesting facts about my solar generation in 2025 that I got from Gemini's analysis of my data. I had Gemini ignore all generation values below 1,000 watts. The maximum value for solar generation was 15.5 kilowatts, and that happened on March 13th at 3:12 p.m. The average or mean was just over 5.9 kilowatts per sample, with the median being somewhat lower at 4.85 kilowatts per sample, and the mode being 1,002 watts per sample. Gemini gives this additional analysis. Because the mean greater than median greater than mode, the data has a right-skewed, positively skewed distribution. Looking at the entire year of 2025, Gemini computed that the overall power usage exceeded solar generation by 463 kilowatt-hours, which is pretty close to break-even. However, our power utility looks at it from the year starting April 1st and going until March 31st of the next year. By that standard, solar generation slightly exceeded usage. July, it turns out, had the highest amount of power exported back to the grid, and July was hotter than usual. On 177 of the days of the year, solar generated exceeded usage, or just less than half of the days of the year. Interestingly, on August 21st, the house was completely independent from the grid entirely for almost 11.5 hours. The low temperature on that day was 45 degrees Fahrenheit, 7 Celsius, and the high temperature was 81 degrees Fahrenheit, 27 Celsius. I'm very pleased with how the system is operating. Here's a yearly comparison of solar production, comparing by month, along with a cumulative total for the year. This year's total production, in red, was 19.34 megawatt-hours. This is the highest ever since the system was installed. I'm super pleased with this total generation. Here's a yearly comparison of energy usage, by month of the year. A total of 18.59 megawatt-hours of electricity was consumed for the year, as opposed to 19.34 megawatt-hours of electricity generated. This means on a calendar basis, solar production was greater than usage by 749 kilowatt-hours. That's really awesome and shows that the investment is worth it. Thanks for watching. Please give this video a thumbs up so other people will be able to view this video.